So in part A, we have a graph that shows distance in miles traveled, d, that for a car over t hours. And I can see we have a nice straight line that starts at 0, 0. Now, the question says, explain why this graph does or does not represent a proportional relationship between the variables d and t. Now, a proportional relationship is a linear relationship that starts at 0, 0. This is clearly a line and starts at 0, 0. And if I wanted to go a step further, I could actually go ahead and make my slope triangle. In 2 hours, which is my run, I would have traveled 100 miles. That would be fun. Not so much, because that means I have a slope of 100 divided by 2, which is equal to 50 miles per hour. Not really that exciting. So, coming down here, this is what I typed. The graph does represent a proportional relationship because it has a constant rate of change, slope of 50, and this relationship also has a y-intercept of 0, 0. Simple. Coming down to the next question, we have 2 more cars, and this time they've given us a table. And I'm looking at this table, and something does not seem to add up. Now clearly 55 plus 55 is 110. And going backwards, this would start at 0. Over here, can you travel any miles in 0 hours? No. So that would just be 0. That means the first hour, this guy went 77 miles per hour, got a speeding ticket, probably, or maybe not, and then traveled at a snail's pace of 45 miles an hour for the remainder of his trip. I guess these tables are trying to show that, in the end, speeding doesn't pay. Anyways, okay, I can't lie. I speed sometimes.
You speed all the time.
Okay, I speed all the time. But not recklessly. And Tate's laughing at me. So, the question says, determine whether the relationship between the number of hours traveled and the number of miles traveled is proportional for each car. Well, because of what we just talked about in the table, we know that the red car is not proportional, because the red car does not represent a proportional relationship, because, come on, folks. Are you guys done?
Yeah.
Molly, are you done?
Yeah.
Okay. Because it drove 77 miles an hour for the first hour, and after the first hour, the red car drove at a constant rate of 45 miles per hour. That is not proportional, because you'd have to have a constant rate of change for a proportional relationship. The white car does represent a proportional relationship because it has a constant rate of change, in this case 55, and it has a y-intercept of 0, 0. Second question, use the table to explain how you determined your answers. For the red car, I found the difference. The distance driven each hour, and found it was driving at 45 miles per hour. So then I subtracted 45 from the initial 1 hour of 77 miles, and that would give me a y-intercept of 32. And a proportional relationship must have a y-intercept of 0, 0, therefore I can't be a proportional relationship. I followed the same pattern of work for the white car, found it had a slope of 55 miles per hour, and then working backwards found the y-intercept of 0. That is proportional. Finally, the last question, describe how the graph of the distance traveled for each car would support your answer. The graph of the red car would start very steep for the first hour, and then it would have a much more flat slope afterwards. The white car would have a graph that was a straight line starting at 0, 0. Finally, a proportional relationship must have a straight line with no